graph. Remember, let's say if you're working at just a regular imaging center and you don't do any therapy, you might start out with only 50 millicuries, because that might be the most you use. But every 6 hours, so here's 50 millicuries. That'd be 6 hours, 25 millicuries, 12 hours. What they typically do is they'll give you the range. So plus or minus 10% means that you're allowed a range of 110 to 90. So you get two graphs that are following that linearity there. This is probably the quick and dirty way to do it. But basically you just plot on the inside of this. As long as it's between the lines, you're good. Okay? So at 18 hours, 24 hours. Or if you get one of those lineators or the cal checks, you just get it done in 15 minutes. Okay, but this is what you would typically do for a linearity test. Okay, number 42. We'll call it to determine the variations due to the volume in a sample being measured. Okay, yeah, that's your geometry test, right? Then 43, according to California law, radiopharmaceuticals must be assayed for an accuracy of a value plus or minus
5%.
Well, whoa.
California.
Yeah, radiopharmaceuticals. Okay, this is different than your constancy check. Okay, your constancy check is plus or minus 5% because you're always counting the same radioactive source. But prior to injection in patients, you're allowed plus or minus 10%. Does that make sense? Yeah, if you guys work in Maryland or California, it's plus or minus 5% when you do the daily constancy check. Okay? Okay, what test determines how close an instrument is to its true value? Okay, letter B. Okay, accuracy check. Remember, that's only once a year. Okay. Now, according to the NRC, what is the minimum number of radiation sources that must be used for constancy testing? Yeah, letter B. Okay, you always have to have 57 cobalt and 137 cesium. Okay. And then, according to the NRC regulations, sources used for the constancy check must have an activity of less than. The answer is D on this one. That's why typically you're going to see that cesium is about 100 microcuries, and 57 cobalt is typically 5 millicuries, somewhere around there, maybe a little bit more. And number 47, sources used for an accuracy check of a dose calibrator must be certified by the manufacturer as being within plus or minus what of the stated activity? 5%. Yeah, remember, you guys, this comes down to those standard deviations. Okay? In nuclear medicine, remember, we use a 2 standard deviation confidence interval, which is plus or minus 5%. We have a 95% confidence interval. Okay? And then number 48, accuracy testing must be done at installation of the dose calibrator, and then how often thereafter. My answer was E, but change that to after repairs. Okay. Okay, number 49, this is also an NRC requirement. At least one source used for the accuracy test must have a gamma energy within what range? And then this one, think about it for a minute. You can almost through, well, do we have anything that we use? Okay, we don't have any radiopharmaceuticals that are 25 to 50 keV, do we? No. I mean, the closest one we would have is iodine 125, which, how often do you use that? Okay, how about 1 to 2 MeV? Nada, right? How about 100 to 500? That's a better, yeah, there's your answer right there. These other ones, you know, just through, what's the word, you know, elimination process, you can just determine that you don't which one it is. They're not going to have you do something you don't use. Number 50, when should the constancy check be done on the dose calibrator? Right. Beginning of the workday. You don't want to find out at the end of the day that you were off by 50%. Now your patients are bursting into flame. Right? Okay, then the source used for a constancy check must not be less than, again, that's 50 microcuries. And then on number 52, according to the NRC, we said 2 sources. I'm kind of repeating myself. You did that when you get older. Brain starts shutting off on you. It's the lack of blood supply. Okay, 53. According to the NRC, the dose calibrator has preset channel buttons for each radionuclide. Which statement is true? Okay, letter B. Yeah, the channel check is recommended, but it's not a requirement. Okay, to get the last one right, I'll give you a break for a few minutes, and then we can get ready to start on the other one here. According to the NRC, a dose calibrator should be repaired or replaced if the accuracy or precision exceed more than what?
10%.
Okay, letter C. And that's in your math book, too. Okay, why don't you take about a short break,